Good morning everybody. So today I'm going to explain you the central conicoids. So let us start with the introduction of central conicoids. In 2D we called it like a conic, but in the 3D structures we said they are the conicoids. So firstly we discuss about the standard equation of the conicoid. So if there is any point on a x or y z axis, that is alpha, beta, gamma, it says that all the chords of that conicoid should be passes through the origin. In this it has a standard equation, that is ax square plus b by square plus cz square is equal to 1, where we see that that capital A is equal to 1 upon small a square, and capital B is equal to 1 upon small b square, and c is equal to small c square. Now secondly we discuss about the nature and the shapes of central conicoids. The value of the A, B, C. First we have make 3 or 4 parts of this page to explain all the things. First we discuss about the value of A, B, C. Secondly we discuss about the nature of the central conicoids, and thirdly we discuss about the equation that it had. So the first is, if A, B, C all are positive, then the nature of the central conicoid is the ellipsoid. Here we see in the figure 1, that is, it is the figure of ellipsoid. We see over here there is a 3D structure because it had x-axis, y-axis and z-axis as well, and all the axes are passes through the origin. All the chords of this are passing from the origin. So we understand that it is a ellipsoid, and all the values of A, B, C are positive. So the equation will be x square upon a square plus y square upon b square plus z square upon c square is equal to 1. We have convert the standard equation of the central conicoid into this equation by putting the value of A, B, C, and as all the values A, B, C are positive, so it is in this form. Secondly we discuss about the second condition, is that if A, B are positive but C is negative. So here we see in the figure that it is the hyperboloid of one sheet, because it has two types. That hyperbola is of 2 sheets, and the second is the hyperbola of 1 sheet. So the first equation of the hyperbola of 1 sheet is x square upon a square plus y square upon b square minus z square upon c square is equal to 1. As here we see the value of c is negative, so we minus the z-axis. So here we see that it is the hyperbola of 1 sheet. Thirdly we discuss about the, if A is negative, if A is positive but the B and C are negative, then it is the nature of central conicoid, that is hyperboloid of 2 sheets. 2 sheet, that means it has a equation, that is x squared upon a square minus y square upon a square minus z square upon c square is equal to 1. Here also we see that in the figure number 3, it also a 3D figure, that it has x-axis, y-axis and z-axis as well. So that is all about the 3 cases, 3 natures of the central conicoids. Now next we discuss about one special case. Now I'm going to explain the one special case, that is if all the values that are a, b, c if negative. So here we see that is imaginary ellipsoid, that is the equation minus x square upon a square minus y square upon b square minus z square upon c square is equal to 1. Why we called it as the imaginary ellipsoids? Because all the value of a, b, c all are negative, so it is called imaginary. Now let us find out one question related to central conicoids, that is here we see the question that find the center of the conicoid having equation 2x square plus 3y square plus 4z square minus 8x plus 6y minus 16z plus 5 is equal to 0. So now before doing this question, we see that the formula of central coordinates, that is minus u upon a minus v upon v minus w upon c. So from the equation we find that a is equal to 2 and b is equal to 3 and c is equal to 4. From the equation also we find u is equal to minus 4, v is equal to 3 and w is equal to minus 8. So how we find these values? These value we find from the general equation, that is we find these values from compare the equation with the general equation of central conicoid, that is ax square plus vy square plus cz square plus 2ux plus 2vy plus 2wz plus t is equal to 0. So on putting these values in the central coordinates, we find that the center of the conicoid is 2 minus 1 2. So this is the final answer of our question. From the formulas of these we can find a lot of questions, because in semester exams we have these types of questions, so we can easily find out the multiple choice questions from this. So that is all about for my presentation. Thank you so much.